Right. This doesn't happen, apparently. The first extreme is being added here. Why am I not setting H direction then afterwards? So yeah, again this else here. I vaguely remember that days ago, a week ago, I added an else here. For some reason. Let's try to understand this. So what I did here is fit a 4th degree polynomial. Like here. And then we find the two extremes of that. Mean a 4th degree polynomials like say so, and then one extreme and another one. The maximum, the two maxima. This is still unclear, I must say. This is talking about the parabolic approximation that I had. I mean, it's like if you have two relevant symbols, then we can have a parabolic approximation. And then if the last step was super small, that means that we are in the minimum of that parabolic approximation. And then as a result, well, super small, I don't know, 1% of the current scale, whatever that is. And then I fit a 4th degree parabola. 4th degree parabola. I'm slowly losing my sanity here. Polynomial. And then after having fitted the 4th degree polynomial, I'm doing again this test. It's kind of the exact same test as I did already. The absolute step is less than 1% of the parabolic approximation scale. The absolute step is set to, no, it's not changed. So I do this. If the absolute step is less than 1% of the parabolic approximation, then we do stuff. And then I do the same test. And the V direction is up. I'm using 5%. Hello. And I don't think that parabolic approximation changing either. So this is always true, isn't it? It's really, really weird, man. Maybe I should remove this and maybe use the 5% for the maxima, which do not need to be that accurate. I don't know. Okay, so I'm just continuing then after fitting the fourth degree polynomial. And the first time I get here, the horizontal direction has not been decided yet. We don't know if we want to go left or right. Then we add that extreme, which the first case should always be a minimum, aka I think it should be a minimum. Meaning that the vertical direction was down, so we do get here. Which means that the best minimum is being set. Because this is still true. Did not have a best minimum yet. And this is always false. Because we just said it. So the first time that we get here with step count is not equal to a board. And the best minimum is being set. So the best minimum is unequal end. And the v direction must be down. So let's test all that. But how to test that this was the first time that we got here? Well, I would think that the first time we get here is the only time that a direction must be on. Do that, but that's the whole bug. No, there's always something added. I never remove it. So it's simply the first time that we got here means that the number of elements in the extremes container is 1. So size is unequal 1. So now we have the case where this was the first time. So the first time, I think v direction must always be down. And of course, the best minimum must be unequal to the end. It must be set now. And step kind, yeah, I don't have to test it. Yeah, I'll test it anyway. It's unequal board. Now, if the number of zeros that I found was larger than 0, which might be not the case, I have to admit. Then we can determine which is the best one. I mean, if you have only 1 0, that's the best one. If you have 2 zeros, then it is determined by which side is looking lower. And then we set well, then hdirection must be set depending on that. So when there was an else here, that was definitely not happening. If we do not have any zeros, then what? I get here. Just keep going in the same direction. And in that case, I think the value of W was this. So now it is W minus that equals Okay, this is confusing. Let me add some comment. So if the edge sample is on the right of the vertex, and we went from the edge sample to the vertex going left, and then we continue left by subtracting the positive scale from it. In the opposite case, if were the edge sample is on the right, on the left, then the then the scale is negative, because maybe I should just add it as well. Right? The stupid thing is that now this must match that story. Now the current means the last sample that was stored. I think that W is that thing, well, before I change it anyway, and it isn't. Damn it, it could be a... Oh, sorry, it's changed. Yeah, and, it's not changed here because the number 0 equals 0 for this particular case. So then what is W? Yeah, I think that... This is where it was set in this scope, wasn't it? To just comment it out. I don't have music anymore. It's unbelievable. Okay. So this is, we do not get here because you can't find any zeros. Yeah, so in this case W is still equal to this value. That's not current. That's close to current probably, because current is then this difference with the W. Yeah, step is now, it's before I had this, but so now I'm saying step is actually, I think this W is current. Let me check that. Do this else, so that came from here. Let's assume we do not have only one sample. I had a certain weight value, W, which then was used to add to the history. So at this point, W is the W value of current. And only if we add something else to the history, which I'm not doing anymore, well, except in one place, but even that's going to be changed. This is going to be the only place where it is added. W equals the W value of current, unless we already change W, which happens here, but that would be when we have only one relevant sample, which what means that we do not have a parabolic approximation. I don't even want to think about that case at the moment. We don't get here because we get here. And then it is set to the parabolic, to the vertex already. And step is then that difference. And that means that at least it is very close to that value. Because we only get here when the absolute value of the step is less than 1% of the scale. So W is more or less the same as the W value. Even after this, it's more or less the same as the W value of current. But not exactly. So that is not correct then. I'd rather do it exactly. So this is not correct then. On the other hand, it is correct, because in this case, W was within 1% of was equal to the current value, W, plus or minus 1% of the scale. So we then subtract scale, then obviously it's going to be left or right, like 99% of the scale of the zero, this difference. So it does work. Yeah, so if the number of zeros is larger than 0, then I do get this. And now we pick the best 0, which overrides the previous assignment of W. We are no longer at the vertex of the current parabola. Which means that I have to reset the scale, which is still commented out. The history is reset. Yeah, this needs to be fixed. But okay. We jump to the base 0, which is then left or right of the previous value. And that previous value is indeed... And then this. And then we see if we jump left or right. And this then determines direction. So the else should not be here. So how can I detect? I mean, I rather first see that this goes wrong before I fix it. That kind of double check on if my fix is correct. Plus, it strengthens my understanding of the situation. Certainly, if I can predict it. So by not resetting the scale here, what will go wrong? So we just jump to a 0 of the 4th degree polynomial fit, which could be just, yeah, pretty far out somewhere. And we definitely get into a region that does not belong to the current parabola approximation anymore. So by not resetting it, I think it's just going to use this W value and the previous one as if they are both part of a parabola, as it's the same parabola, and then, you know, improve the approximation, which is just nonsense. I think I already saw that actually, so we can see that in action again in a bit, and then I'm going to fix it and hopefully that disappears. So I'm using this as a test at the moment. No, this is already not good, of course. I mean, no matter what is going on here, it does find back eventually the minimum here. And then it fits a 4th degree polynomial, which is the green one here. So it goes here, and then nice fit, and then it kind of, you see, I mean, it kind of sees that it goes down. You know, this is a sinus opposed upon a parabola, a big parabola here, and we see the difference. The asymmetry here is caused by the parabola. So independent of the fact that there is a sign on top of it, you just see that it goes down from there to there. This maximum is higher than that one. So this finding the maximum means we have to find the zero of the derivative of this curve. So the derivative is this purple thing. It's just a derivative of that. And now we have to find the zero. So we have to find this is 0 here. We have to find this 0 and this 0. But the third degree has 4 zeros, 3 zeros, 1, 2, 3. But we can easily get rid of this one because that is the one that we just found here. That is the minimum in this point. I mean, that's also has also a derivative of 0, obviously. This is the what we just fitted. So as divide that one out, and then you get this blue parabola, which just has a 0 there and there, which is easy to solve. Okay, so now when we find the best 0, and the best 0 is this one, because that maximum is lower. So now we're going to jump here, which is then ending up here on the curve in point 8. And now you see where it goes wrong, because I did not reset the scale. It's not saying, okay, now I have just 1 point. It's saying I have 2 points, namely 8 and 7, and it still fits a parabola through that. So the parabolic approximation was, that's not drawn anymore, but it was something else. And now it's improving it, basing it on 0.8, but also 0.7. Which is at 7.6, which is probably where we came from. Huh? That's just the vertex. Fitting a parabola through these 2 points is bullshit. We would even want to go back now here. I don't think that's happening though, because we now already decided on the direction that we are going into. Well, I should yeah, this was not there before. So now the horizontal direction has been decided on to go to the right, because you picked the right of the 2 zeros. And then what happens if the new parabolic approximation has a vertex that is on the left is that it says, yeah, I don't want to go that way, so let's just take a little step. So I think that it is going to add a 9, or it already did, which is so little that you don't even see the difference, right? See, 0.9 is added there. What was 8? That's kind of strange. 8 was at 15.72. So it did not go to the right. 0.9 is tiny little bit to the left. Huh? How was that calculated then? Guess I might as well stop here because it's not correct. No. Well, whether or not it's a little bit to the left or the right of 0.8 doesn't matter. You get this parabola anyway. So the next step is then 0.10. And then we find the maximum here at some point. You got to be kidding me. This is fitting a 4th degree polynomial. That should not happen, I think. Pretty sure that should only happen for the minimum, when we find a minimum, not the maximum. We should just continue in that direction. Or is that nonsense? Guess it works as well. So we're gonna go now to the lowest of these two, 13. And then again, because the scale was not reset, the first parabola is just bullshit. But we continue in this direction anyway. I think again a very small step. 13 and 14 are just almost in the same point here. What happened here? 14. Can't even see a difference here. So small. I don't like that at all. I want to know how those values are determined, really. Almost seems random. No, 13 is at 26. 26.26, I mean, instead of 26.28. So 14 is on the tiny little bit on the right, so at least that works or is correct. Again, we find this minimum, and then we find that, and then we find that. And now something goes wrong, which is interesting. The fourth degree polynomial that is being fit in this maximum is super wide. How strange is that? Doesn't even remotely fit. Well, previously we saw something that fits here, and then it just goes up again, like that. And here too. But now we completely missed the real minimum, and it just jumps there. What? Why? That's not a problem, I think. It's very suspicious that... oh, I pressed a button accidentally. So all this time it was a nice snug fit, and then yeah, we bend away, but closely. So we just, these maxima just give me the next extreme. Until we get here, and now for some reason it doesn't bend back. Why? Let's see. This has been based on these three samples, which is not printing the labels of them. Damage. 39.4. I guess that's the one in the top here. 39. Looks also in the top to me. And 38.9, which is almost the same place as that one. And what? I want to know which. Just highlight that value. This is 0.20. Okay, that's in the top. And this is 21. That must also be the top then. And this is 22. 20, 21, and 22. They're all three in the top. Yeah, well, I guess that can happen. I did try to battle that by saying that if 2 points are too close to each other, that is within something of the scale, then I kind of ignore it. I would rather not have used one of these points because they are like super close together, aren't they? Would have been better to use 18 and 2 of these maybe, and then 18. But okay, it's a nice test. So because all the points are here, we now miss the fact that it's curving up again, just too close together at the top. And we miss the actual minimum jumping here. Then what happens? Oops. And then again, it just fits a random parabola because it takes a point here. I should fix that. And then we get the real one. And then what happens here? It opens the debugger. What? Why? What? I'm mostly confused about the fact that this is apparently the first time we get here. We've been finding minimum before. Oh, this is changing direction. Yeah, restore the current sample. So what it did is, I'm just gonna quit it. What it did is determine that this minimum is not lower than that minimum. It's the last one that we found, I think. Although, if I keep minima, they should still be drawn. So now I'm confused that there is no cross here at the minimum. All extremes should be kept. That's not a problem. Anyway, let's say it said this is not, we were going to the right and this is not lower than one that we had before. Therefore, I stopped going in that direction. So I now want to go in the left direction. And that should make us go here, but there's no cross here. What the hell? Why is there no pointer? What is happening? What? That's also not working. It jumps, I don't know. Again, past the real minimum. Now what would happen? I mean, if we're going to the left, then we should go to 32. Yeah, we are. Okay. And now this, of course, not lower than the best minimum that we did find. So now it's gonna terminate because this was higher and we went to the right until the minimum was higher than we found before. And then we went to the left until we found a minimum that is higher. And at that point I stop. I hope. Yep. And then it says found a global minimum value minus 0.95. Well, the real one has a -1 as a value at 28.5. So that is this one. That's the lowest. So this one is lower than that one, apparently, a little bit. But yeah, I missed the real minimum because it jumped over it twice. Now, low-hanging fruit is, of course, resetting the scale, but I'm kind of scared that if I do that I might miss all the other nice bugs that we saw. So I have to at least make a list of them. I'm just gonna write it down, I think. Piece of paper. Okay, the first one is reset scale after jumping to best 0. So when you jump to this extreme here of the 4th degree polynomial, then I should forget about this parabolic approximation. I'm saying it again. No, I'm not saying it again. Okay. I think it should be detected that this is just wrong. So this point here is extremely far off from the prediction, namely the green curve, which is not even visible. I think that goes like down, 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 down. So you would have expected to get at minus 10 or something, and we end up at minus 0.9. So something's wrong. Going to write that down then. Okay, so detect. Detect if we jumped too far. Holds for all jumps actually. I don't know why I'm getting here for the first time. No, I already understood that because we just changed direction. Yeah. This was a big mystery. Do. It jumps to 27, yeah. Why not to this point? Maybe we should look in the debugger. Do we step at the size equal to the scale in this minimum? What minimum? Well, this is the 28.58. So the scale was 8. Oh, that really sucks that I lost my graph though. Completely gone. Let me think. What if I put it on this monitor? And then close it. That didn't work, I think. It did work. Cool. You think this thing sits in layer dock? Why not just top? Well, apparently one time I couldn't find the debugger window, so I put it in dock. Like, let's never have that happen again. Yeah, to make this big, switch profile to YouTube. And then I'm going to set this one to dock. Ah, fuck, even that without it. Okay, well, maybe you still have the information that I wanted. Stupid. Okay, so next. Oh, it did redraw it. Great. Okay, so print the current parabolic approximation, which says that it has a scale of 8 and vertex was, I saw somewhere 28 something. I'm gonna calculate it, I think, from the parabola. And it's 3.4927. $38.988. It's not a minimum. Yeah. Rather no. Let me put this here. This one. Go to make a new tab. What was this one still on? No, it's not. The debugger frame 1. Yeah, that's why I said what minimum, because I expected that it was not a minimum. So what is wrong then? Why am I jumping to this point? That's definitely not correct. Huh? Jump to the best minimum and then we jump to one of the maximum, local maximum. What? The best minimum, how often is that set? First time it is set, it is at 7.6. So that's here. And then the second time it is set is at 28.5, which is here. That's a bare minimum. And that is the last time it was set. And then it says restore W to the best minimum at 28.5, which should be this one. But in the debugger, I find this thing here. So if I go to the code, okay, now I'm lost. Oh yeah, that is set, and we print that that is a minimum, as it should. Then we go into the debugger, and I'm currently in the debugger on this line. So I can print the contents of this, whatever it points to. And doing so, I get this problem with these coefficients, which belongs to that maximum here, not this minimum. Can someone explain that? You can just do this value divided by 2 times that value, and then you get the vertex x coordinate, which is here. But you can also just look at this coefficient, which is negative, which means that we are going to minus infinity, where x goes to minus infinity or plus infinity. So it's a problem that width has a maximum, because this is negative. So it's definitely not a minimum, yeah? This is this plus that times w plus this negative value times w squared, or minus positive times, no, whatever. Now, to think, why is this happening? Well, this is the correct value. I think it's time to look at what best minimum is. Best minimum is an iterator. 2. The extremes type, which is a list of plot sample minimum. Which is derived from sample minimum. That's what we store, right? Storing in the extremes container, which is a standard list, I store plot sample minimum objects, which means that we also store as the base class part of that It's the gradient descent sample minimum. Which contains the parabolic approximation as an object. But you can get write access to it. It's a non-cons reference that is returned to you. So I would think that someone, after we stored this, called this function and then changed it into a completely different approximation, which is which is very likely the result of not resetting my scale. So I'm jumping away and I'm not resetting the scale. Okay, I'm not telling it that we're leaving the approximation parabola. Let's say this parabola is being fitted, and then I jump to this one without resetting it, and therefore it says, oh, I have to update this parabola to be better, namely this parabola. And then it overwrites it. That's what happened. Yeah. Well, I could, of course, still say, well, I just reset the scale, or forget about the previous parabola. But I'm a bit worried about that the same situation can happen in different circumstances. There must be some kind of detection, I think, that if we try to replace a parabola with another parabola that is just completely different, well, yeah, that's not good. Improvement is allowed, but not rewrite with something else. Let me write that down as well. Detect, between quotes, rewrite of parabolic approximations of any of extremes. That's the name of the container where they are stored in. Yeah, well, I don't. Let's fix these things so far. Let's begin with the reset. This is not the only jump. I have another jump, so maybe you can copy the code that I used there. Let me look again for where my W is being changed. Dude. Here it is being set, that's a jump, and here it is updated. So this should stay on the same parabola, but what if it doesn't? Or was it already reset there? This is also a jump. The reset here happens here. This whole block actually. Just the only other jump that I have. I guess that any jump is an assignment, yeah, not an increment like here. Search for anything that starts with space. And then for main, really. On the top, main, that. Here's another one. Well, wait a minute. This is not really a jump. Well, it jumps to the vertex of the current parabola. So it definitely stays on the parabola. But then it has that intention. This jumps to a different parabola, so you definitely need a reset here. And this jumps to a last minimum, a previous minimum. So definitely a jump. Gradient descent, yeah, you can Google it. So on YouTube, there's also lots of. Okay, I'll give you a link. I still have it open. Do I still have it open? I'll give you a link. I'm going to give you a link. Saved messages. Yeah. Copy. Link. Paste. Ding. This switches the parabolic approximation pointer away from the stack. I think it was on the stack anyway. To the one stored in this minimum. Changes W away from that. Erase the indicators of the previous one. No, this is just changed it. Oh, this is the plot scale. That wasn't changed yet. Interesting. It's very shortly at that point. Points very shortly to the parabolic approximation that belongs to this minimum. Apparently just to get the scale of it. And then I reset it anyway. Well, theoretically I would still be on it. But yeah, we're going away from it. Might as well forget about it. We're not going to the vertex of this parabola. So it's reasonable to reset it here. So then I switch to the thing on the stack. And this is the sibling, which, well, for the scale anyway. Plotting stuff with relationship to the scale of that parabolic approximation is stored in a different object. So these two go as a pair. And then the whole parabolic approximation is reset, but it's not the one that was in the minimum, but the thing that we work with right now. And I guess I'm going to copy all of this because I can't remember it. Now we get here. We jump to the best 0. And then you got to wonder where do we come from? Come from this parabola, which we just found a minimum or maximum of, and that was just stored as extreme. Where this parabolic approximation is a reference to whatever my pointer is pointing at. But what is the pointer pointing to? I think I don't know. Could be a minimum. Previous minimum or not? Not really. I mean, at the moment I set the pointer to point to a minimum, to a past extreme. I'll immediately move it away from it again. What? I think that was the only place where that happens. Okay, I lost it. Let's forget what I have in my mouse buffer. I rather I need my mouse again. I want to see what this pointer is all being set. This initialization, I set it to a thing on the stack here. And then it is set here to the parabolic approximation of that extreme that we just stored. Well, that happens here anyway. Okay, so every time we find a new extreme and store that in extremes, then also the pointer points from that moment on to that extreme. And if something is aborted, then we jump to another best minimum, then it's very shortly set to that thing, but I immediately change to the stack again. So that's when you change the direction. So that is after aborting a direction. So after storing an extreme, it points to the extreme, and then it's pointing back to the stack only after aborting. Then I'm pretty sure that at the moment we find an extreme, it's pointing to the parabolic approximation stored in that extreme. So here we did find an extreme, therefore it must be pointing to that place. So I can storing to the extreme, yeah. I want to copy that stuff again, here this, I think I copied this. So let's paste that here. Let's see if I can make any change of it. Shift V. R3. So this comment now is correct because we are we are pointing to the current minimum, as it were, and then and I want to switch to the stack again, which is this code, right? Erase any indicators of the previous one, switch to the stack, actually reset the parabolic approximation. So the erase indicators has been copied. That was used here, now it's used again. And the scale reset is this call. And I'm also switching to a scratch area thing on the stack. The difference is that in this case, either we kept the scale despite resetting it, or the scale was set to the difference between the two zeros. Yeah. I think I kind of redefined what scale means, so this would no longer apply. So information that I'm not using anymore then. Gotta see what this is doing. Absolutely random. So what happened after this? Now we jump to 8. And then we should forget about the previous parabola, including not using any of these points anymore to fit another parabola. So I think it should be a straight line. And it isn't. What the hell? Still using 7 and 8. Can talk. That one is also dog for some reason. Yeah, I understand now. It's being redrawn because that's done in a different thread. So we're debugging this thread, but the other thread just got a signal from the X server that it needs to be redrawn because another window has been covering it, so it's got an expose event. Okay, so next is best zero is blah blah blah. And now we're going to not reset apparently. A bit confusing here. I'd expected my 8 already to be visible. Placing 0.7. 8 is not there yet. No, 8 is, yeah, okay, we're going to calculate that now. So next. W, that's 15.7, that's here. And now we erase indicators, really? At this point, before 8 even exists. Well, okay. As long as I forget 7. Oh, no. So that did remove the scale. You had the dotted line and scale, and they're gone. Probably still there though, but okay. Maybe that's reset when I call the reset function. We set back to the stack, and I think that is indeed making a change, right? Next. It's not changing it, so it was already on the stack. Why? Strange. Let's see what this does. Number of samples is the relevant sample set to 0. Totally should not use 7 then. Unless I add 7 after this point. But I don't think so. Do I? No. I think so. Anyway, we don't. It's completely reset. This thing is reset. Okay. The scale is reset. Oh boy. Into the debugging code. History reset. Tell you found extreme at 15.7. It did. Does it look like 15.7? So I don't know what is it talking about, but that probably I'm not looking straight. Yeah, this must be. This is 15.7. Next. Best 0 was that. Kind of confused why the probe are still there. Shouldn't that have been erased? Again, we just did that. What is this for nonsense? What? Now it's being pointed to new extreme. Oh, and that is this one. It's it's being an itch. I think we just found this point and didn't store it yet. Okay, so it apparently happens is we find the minimum here. Then I do my 4th degree polynomial fit, then I find this point, then I do a reset of something that doesn't exist yet, and then we store this minimum and switch to it. So the whole reset missed the missed that initialization. Yeah, that's kind of nonsense. 891. So this should only happen if we do not jump. So that belongs to the else. Here I do jump. What? Yeah, I'm not doing this here. Let's just do this here in an else. Okay, yeah, that's better, I guess. Yeah, I definitely forgot about this rule now. So we start over. Start over in this point here. My debugger is still starting, which is annoying. I don't need that anymore. Quit. What is this? I'm talking about this red line here at the top. Oh, it's a black line together with the orange line. Looks a bit red. It's just the energy, I guess. That's a huge scale. Ridiculous. It's completely failing. Now, what was the next point? I wrote it down. Reset scale after jumping to the best zero. I just did that. Detect if we jump too far. Detect the rewrites of the parabolic approximation of extremes. Let's do that first, I guess. That wouldn't solve anything yet. Yeah. So here I'm setting it to extreme, sorry, to the parabolic approximation belonging to an extreme that we already found, right? Or not? Yeah, otherwise it's not an extreme. To the minimum, the vertex is already known. I think that the only thing that is allowed afterwards is changing the scale, not the parabolic approximation. So that would be an easy detection. Here, like I said, here it's temporarily set to something, but not really, because I'm immediately overriding it. I'm just using it here, so maybe I should use a different variable. Let's call this best minimum. Well, it must be a reference. Best minimum parabolic approximation. And this is not true even. Not doing that. Do a step with the size equal to the scale in this minimum. We expect it to be a parabola up till that point. No, we don't. Because afterwards I completely switch again anyway. Well, maybe it's we don't expect to miss all kinds of details. I'm just going to use this thing directly, I think. Okay, so here I have it set. Here I set it to the stack. I'm going to start from the top again. Initialization. Here I set it to the stack. Here we set it to an extreme that was just stored. And here we set it to the stack again. In other words, this is the only place where this thing is set to an extreme. Well, to a minimum thing, and that it already has that. I mean, it already has its minimum determined and everything. Now afterwards, an update can happen by calling update on it. To somewhere I'm calling update. Probably down. Oh, update is called from a different file, I think, actually. It's more like part of add. This add. So I just changed this pointer. So this reference now pointing to the parabolic approximation of my minimum. And then we might add a new sample to it. It is then an add of the parabolic approximation, which does the following thing. That is this function. Which potentially changes the problem. But I don't think this can be true. Number of relevant samples is not reset. It should never be reset. I think I need to add a debug thingy. Let me to begin with that. So I'll have a parabolic approximation. For debugging purposes, it's kind of necessary to know if it is a minimum or not. Minimum was stored in sample minimum, skill minimum, sample minimum. Yep, this one. So I want that to be set then as part of the constructor. Add a comma CW debug only. A bool is part of minimum, which is by default false. Okay, what did it do? I added it to add. No, dude. Wanted it to be a constructor. So we have to construct it with a true value if it is sample minimum. This constructor as a parabolic. Oh, wait a minute. Huh? Oh no, it didn't. Sample. Oh, it's copied. Oh shit. Yeah, this is never default constructed. It's just always copied. So let's make it a pseudo copy operator. Pass it through there. Or yeah, that kind of sucks as well. Let's just use a copy constructor and then set it. Default is false, but then if it is part of sample minimum, then this is called and then it's true. And that all for debugging. And now I can use it, but where? In the add function, I guess. I guess English is like that, no apostrophe. Anyway, assert, yeah, no, okay. And then we get here and I changed it anyway. And there again. Why? You would almost think that I just should not call this at all. Because the only thing I can think of is to make sure that it isn't changed. Or at least not much. But no, if we already determined the vertex, then it would be extremely weird to change it. I think it's better to just not call it at all. It's going to be a lame assert, but okay. Sample minimum should only store parabola of which the vertex was already determined. And changing it by adding a new sample would be bullshit, nonsense, incorrect, a bug, weird. Let it assert. Use of undeclared identifier parabolic approximation. No idea. I deleted a line here which tells the truth, but what was that line? Uh-oh. I changed too much. It's no longer in the div even. What? No, can't. Impossible. Shit. Oh, it's a function. So is it like best minimum? Yup. No, my new assert did not fire. Why? Oh, because, yeah, never mind. This was just something on my to-do list, but I already evaded it. So there was a detect rewrites of parabolic approximations of extremes. Nevertheless, I'm kind of surprised that it did not assert. I mean, that would mean that we never get here with a parabolic approximation pointing to an extreme. Seems pretty unlikely. Or the thing never got set. To do something strange, let's add an accessor for this that returns a const reference, so I can't change it. No, it is nonsense. Yeah, it is nonsense. Hello, King Billionaire. Well, I was starting to think about going for a walk though. Where is it? The sun was shining. Well, it was, literally was shining. Not really anymore. I should go for a walk though. Definitely should go for a walk. I think I'm going for a walk. Yeah. I don't know. This is again I don't know, yeah, I fixed some stuff, but what's on my list is detect if we jump too far, still there. The whole detection needs to be there, but I'm also not happy that we can't predict it better. And we can predict it better, but just spreading out those points a little bit. Dude, why am I using 3 points almost on top of each other? It's ridiculous. Ridiculous. Do I have a scale at this point? Around 40, 39? Before we do that, scale. So I'm having a scale here which includes 20 or whatever it says here, 20 and 21. Looks like it. And anything else should be including these points. So the scale should not change, I think. Still there, see? Still there. Okay, maybe I should not have erased the scale just yet. But yeah, it already added 0.26 here. So that has nothing to do with this anymore. The point being that since I added 20, I know that it is like a parabola in this range, this horizontal range. All of this is a parabola. So why would I accept 3 points that are on top of each other? Like super close compared to the sample. So it's, sorry, compared to the scale. It's just not nice. Why do I have 3 anyway? Normally I have like 1 and then the next one finds the minimum. Or the maximum in this case. And then the third one is still there. Now we have jump and then again and still didn't find it, and then we find it, and then the last 3 are very close to each other. Apparently not so close that I'm using it to replace stuff, but I think that the replace only happens when I'm scared to divide by 0, which is not the case here. So for parabola fitting it does work, but for the 4th degree one I should probably use the edge sample to begin with. So we have the edge sample, we have an extreme. What about I just add one more test case on the other side? Say that I just jump, say, I don't know, do one more measurement here. Well, this is not no fun either, if you can avoid that. I could go from the extreme distance of, say, the half the scale, because it wasn't explored yet to that side. And then fit something through that. It's kind of work with the sign, it's going to work. But what if you have something like, and then it's going up again. Although, actually it works as well, I think. I mean, it's a 4th degree. It looks like a 3rd degree. So my 4th degree would still fit it. Yeah. It's a better attempt at what I'm doing now. Doing what I know, this leads to my fourth degree thinking that it is a problem. Okay, I'm going to think about this while having my walk. I'm walking like an hour, I think. Walking through the forest to the other side and then all the way back and then into the village center where I drink a cup of tea. And then on my way home I pass the balcony of a friend, a woman friend. And if she waves at me, then maybe I'll stick around. I don't know. She's home. We're going to play memory. Maybe we should ask in advance so I can bring it. Nah. I'll be back later.